because they're not so much worried about moisture. Yeah, there's always moisture in the air, but as you get to higher altitudes, you experience more moisture and more stuff in the air. And these ones are less expensive, obviously, because they don't do as much. They're not as heavy duty as the all-weather ones are. And just like we did last week, we had the spark plug up there. It told you what engine it went for. It'll tell you if it's going to be an all-weather one or not. Everybody got that down? Okay. So, here's the difference, one versus the other. I know pictures can be kind of deceiving and maybe hard to tell the difference, but the all-weather one is in fact bigger than just the regular shielded one. And it's going to have a longer barrel because the cigarette that goes in, the insulator, is going to be longer. It's going to have a seal. It's going to be a rubber one, and that's why it's a little bit longer. It's just more heavy duty. But that's what they'll look like. Everybody see that? Yeah, okay. Alright. So, shielded terminal design. So, all of these types will have a spring, an insulated ignition cable. Like I told you, we talked about the 3 different ones right here. Alright. So whether it's an all-weather type or just a regular one, they will all have these in there. So there'll be a spring in there. There'll be an insulated ignition cable. Termination end, just like I told you before, I'll show you different pictures of them, but they usually come in plastic, silicone, or ceramic. Usually if you see them in silicone, that's a big indication that it is an all-weather one. And then you have a metal sleeve type ignition cable that has a nut that you screw down. So, just like I said, this is going to be a silicone rubber. It's going to be an all-weather seal versus regular shielding one. This one looks to be plastic, or they can be ceramic. They come in different colors. You can see one's green, blue, whatever. Yeah, orange. And all the colors, white. I've even seen white. So they come in different colors. So that's what we're talking about. We're talking about the all-weather. You're going to be looking at this because when it pushes down, it's going to seal. When you screw down the nut, they both have a spring. Nut to screw it down. Everybody see that? Pretty easy? Okay. And then he showed you that picture again. So.
Careful.
Careful?
Be careful with the whole pack.
Yes. You can break these. Actually, most of the damage caused to these is by mishandling. People are yanking them out, talking to their buddies, not paying attention. There's a lot of stuff that can be in your way when pulling out these leads. So like Joseph said, this one is for flexibility, so if you have to come down at a little bit of an angle, they're two pieces, so they're broken off there, so they'll pull right out. Okay? Oops. Just kidding. Okay, spark plug inspection. Everybody got that down? You guys can relax for a minute. There's a bunch of pictures coming up. Yeah, it's exciting, right? Okay, so this is a brand new spark plug that just came out of the package. So it has a brand new gasket. There's no cracks in the ceramic. The electrodes look good. This is what a brand new one looks like. Okay? If anybody wants a picture of that, get it? Okay. So there's going to be a bunch of different things you could be looking for when inspecting a spark plug. Your spark plugs is a big indication what's going on with the engine, and you're constantly taking those in and out. So, carbon fouling. How does carbon fouling happen?
Getting too rich.
What?
Too rich.
Too rich.
Burning oil.
Burning oil or too rich? Both?
Well, typically too rich, but if you have bad rings, you can be burning oil.
Yeah, and there's another slide on oil fouling as well. So yeah, like he said, you're burning too rich. You have too much fuel in there. So this is one thing that you might be looking for. And if you have too much of this, is the spark plug going to fire?
Nope.
Why not?
The electrodes are basically insulated from each other.
Okay. So here's another one, oil fouling. Which is another thing that can happen. This one looks like it's dripping. So the same thing's going to happen with this one. It's probably going to go, the spark's going to go through that oil to ground, and it's probably not going to spark. Not to say that it won't spark, but most likely it's not going to. But these are some things that you're going to be looking for when you pull out spark plugs. So you kind of want to know the difference of what you're looking at. So if I've got a top and a bottom spark plug in there and I have a horizontal opposed engine and I got an oil leak inside, which spark plug is probably going to be covered in oil? Bottom one, right? Because it's hanging out on the bottom. Does anybody know a way of getting rid of that? So it's
A torch.
a torch. So most of the time when we have a lot of oil, there is something we can try. It's usually a 50-50 chance that it'll work. But on the ground, usually they'll lean the mixture and run the engine a little bit hotter in hopes that they can burn that off. Sometimes it works, sometimes it doesn't. You don't run it at like ridiculous speeds, but at a moderate speed, about 1500. All right, next one. There's another oil fouling. This one's a little different, isn't it? It's not leaking, right? It's stuck on there, right? It's burnt on there, right? So it's wet.
The thing is, you've got some major problems with engines.
Yeah, most of the time you do, but some of the engines you pull out, you see some of this. It's pretty common, and guys still run their engines on this. Now, you might not, but other people will. When you're in general aviation, there's a wide spectrum of what's good and what's not. And anybody who works in general aviation will agree with that. If you work for an airliner, you work for a big company, there are standards, there are rules, there's black and white. In general aviation, there's not so much black and white.
So would that pass an annual?
We gotta take it out and clean it. And most likely, if you're asking me personally, no, I would probably inspect to see what's going on. But you do see that, it's pretty common to see it in some of the cylinders that they have a oil leak. And you also have other factors when you do an annual, you do compression check and so forth. So, here's another one, fuel fouling. So, in our fuel, we carry a lot of lead in there. So, these little specks you see, I don't know if you can see them so good on the big screen, but these little dots in there. This is just another indication of something going on inside.
If we take down these front lights, the pictures would show a little bit better.
You want to see if we can get those ones to come down? Is that better?
That's good.
Mood lighting, huh? Yeah, I guess you can see this a little better. On my screen, sometimes I can see stuff better on this screen. Sometimes I can see stuff better on the big screen. So is this one gonna fire?
Probably not.
Why not?
It could fire. But what is lead? So why wouldn't it fire? What is the possibility it could not fire?
Lead's an insulator.
The conductor, right, will go through the lead to ground versus going across where we want it to, right?
Oh, it's conductor.
But this one probably could fire. You actually see more of this than you think. When you do so many annuals, you pull out, you see a lot of carbon fouling. None of these look perfect. I don't think I've ever seen any look perfect unless I put them brand new and then I put them back out. So you're going to see a lot of different stuff. And then that can lead to lead fouling. So these big chunks in here. This one probably has a better chance of not firing, I would say, for the same reason. But you can tell that this spark plug is pretty worn just looking at the center electrode. So these are just some things that you'd be looking for when you're looking at your spark plugs. Like I said, they're a big indication of what's going on inside.
There was an engine that I was helping Lyle, the teacher, work on in a 182 RG that was running so poorly and was so broken that we put the plugs in, or we clean them, super well, put the plugs in, run it for 10 minutes on the ground, pull the plugs back out, and it'd be filled completely to the electrodes with fouling, carbon and lead after 10 minutes. Then the guy flew it.
Huh.
Yeah, I don't think I would feel really comfortable with that.
No.
But like you said, general aviation has a wide spectrum of what's right, what's wrong.
Oh, I failed to mention, we did that 5 different times, where we pull plugs out, clean them, run it for 10 minutes, pull plugs out, clean them, run it for 10 minutes, 5 different times. And it still was doing that, and he still wouldn't do it.
Were you doing an annual or something? Or?
Yeah.
Yeah, did Lyle sign it off that it could be flown?
No.
Oh, okay.
But our shop manager did.
Well, that also falls on the shop manager for signing off something that probably shouldn't have been signed off.
Of course, the plane sat on our ramp for a year, for 12 months before we finished the engine, because the guy,
No.
he crashed his other plane. That's why he needed the 182 again. He stuffed his 206, and then needed the 182 again. So
Yeah,
that's why he finally had us finish it.
Yeah, no.
He doesn't belong in the air.
There's a lot of them that don't belong in the air. There's a lot of airplanes that don't belong in the air. But yet they're still out there. So combustion fouling is another one that you could possibly see. Yeah, it's a little different.
It's like cake.
Cake,
It's not like caking material.
caked on.
And
Yeah, does anybody know how that happens?
Gotta do with heating.
Yeah, with mixing the fuel and air mixture, and then sometimes when you're at high humidities, you have that factor involved as well, and you can get a combustion fouling. I'm sure there's many other reasons, but it's basically heating and cooling and the air mixture and what's in the air, and it causes the sticking. So most likely this is probably an airplane that probably flies IFR. Not to say it won't happen on a VFR plane, but most of the time it would be on an IFR. So, and usually your exhaust valve is going to look just like this. All right. So, bridge gap. Will this one fire?
No.
Absolutely not. Okay. This happens quite a bit too. You might get a piece of something stuck in there. But other than that, the spark plug looks great, right? I think so.
Orange, pressure clean.
So,
How does that happen?
that
Sorry,
one?
Go back. The bridge cap, is that just something like I lodged in there? Or what?
Yeah, you might get lead in there. Pieces of lead from the fuel. Carbon. So,
Crickets.
okay. Cracked insulator. How do you think this happens?
Dropping.
Most likely from dropping or over torquing and so forth. These things are pretty fragile, so if you mistreat them, they will break very easily. Is this one going to fire?
Awesome. Maybe.
Maybe, but probably not. It's probably going to ground right through that crack. So here's a broken insulator. This happens a lot from over torquing and dropping as well. A lot of that stuff happens from mishandling. Most of the time, if you drop a spark plug once, it's probably broken and you need to throw it away. You can test them and to see if they're working, but most of the time, they just chuck them in the trash. So, connector well flashover. So, how does this happen? Carbon, anything acting like a conductor will moisture, grease. So it acts like a conductor and it wants to go through the path of least resistance to ground, right? So it's going to ground to the shell versus where we want it to go. It's like a cheery ringtone there. So there's a lot of things that can be conductors. Dirt is another one. You want to make sure these things are really clean when you put them back in. So if you had Kentucky Fried Chicken for lunch, your fingers are all greasy, you laugh, but it does happen. You want to make sure that you don't put that grease anywhere on the spark plug. So, connector well damaged. This is on the other end. This is usually from putting the harness in at an angle, tightening it down too tight. All of this happens very frequently that we end up breaking the ceramic inside. Okay. So removal, service, and installation. So we're going to go through removing and servicing and reinstalling these. telling you how to remove them. I'll show you a picture of it. So remember we talked about earlier, you want to make sure you pull these terminal sleeves in a straight line, preventing damage to the wire sleeve or the spark plug barrel insulator. I'm going to show you guys a picture. It's pretty self-explanatory. Just breaking down how somebody's taken it apart. Okay. You have that written down?
Yeah.
So we're not gonna talk about non-shielded spark plug wire?
We are. We're going to go into that as we finish through shielded wires. We'll go through non-shielded just briefly, because basically they're just
You don't see that.
yeah, we don't see them very much, but basically they're not holding the field inside the shielded wire and bleeding out through the wire or through the shielded part. So that's how you get that radio frequency. Because we're going to go through the non-barrel type, which is basically the ceramic showing. Okay, did everybody get that? So this is just removing the harness part. You're breaking that 7/8 lead, making sure you don't twist the wires you're coming out. And to make sure when you pull it out straight, because if you come at an angle, if it doesn't happen to be one that's cut in half and it's not a all-weather one, you could break it. Or even if it wasn't all-weather and you're yanking it out, it could scrape across the spark plug on the inside, and we don't want that. Okay, so some harness wires may need to be held with an additional smaller wrench to prevent twisting the harness wire during the loosening tightening process. There's a picture in here I'm going to show you guys. Everybody got that? Okay. So, there's a picture of one. So this is going to be your backup wrench. You're going to break it loose. If you don't support this wire, when you're breaking it loose, you could twist everything inside. So everybody see that? Let's see what the next picture looks like. So, we talk about backing it up. So this one has a 3/4 inch wrench. You're going to break it loose. But while you're breaking it loose, you want to make sure you hold this one straight, because if you don't, you could twist this and break it off inside and damage the wires. Seems pretty simple, but it does happen quite often. People are lazy to go grab that second wrench. Did everybody see that? Okay. Unshielded spark plug. This is what you were talking about, right? Yeah. So, these you usually see in older aircraft. Not to say you might see them in something newer, but most of the time you'll see them in older aircrafts. We don't have them generally in newer ones, just for the main reason. Grabbing that resistor, we went through that already last week. So this is what it looks like. So this one's a 4-sided. They're usually pretty small. They're like this big. So, oh wait, I forget to write that down and then we'll talk about it.
Amanda?
Yeah.
So you typically only see these in something that's like being like the people are trying to get period correct or something like that, because you can run other spark plugs in those old engines, right?
No, the harness that hooks up to it, I'll show you how it hooks up. But if
Well,
you
it
put,
has the little prongs, right?
yeah, it has the little prongs in it. So how would you hook up one of the others, the all-weather ones we were just
Is
talking
there an
about?
STC kit or something for it?
You could change out the harness and upgrade it, but I don't know for how many different aircrafts. But the majority of them that generally call out for this, they'll keep them at this.
Makes sense.
But yeah, I'm sure. I mean, there's always upgradable kits for
Everything.
everything. It seems like.
But because like I see like I'll see one of those on like a 20-something Stearman or something like that.
Yeah, usually I see them on radial engines, but I mean, not to say that you won't see them on something else, but most of the time I see them on radials, and they are sometimes they're connected a little differently. There is some of them may be safety wired. You might have to cut the safety wire to take the clip to pull it off. The one I'm going to show you is a little different than that, but there's a couple of different designs out there. Does everybody have that written down? Okay. So this one's pretty simple. You flip this tab, and these two will spread open, and the spark plug will come right out. It's pretty simple design, if you can tell with what he's holding. This isn't shielded, braided shielded material at all. This is actually the wire actually going to the spark plug. So you may see those out there. I've seen them, like I said, I see them mostly on radials. Could be something else, not saying that they're not. I don't know if you guys noticed, but you know it's got 3 little bumps in it? So anybody might know why they might have those bumps in there? Water, yes, water. Because it wants to break up the stream of water on the outside, because you know that these are basically exposed. So they're trying to eliminate the water coming down because it's going to go through the water versus out the spark plug if it wants to go the path of least resistance. This is to break the flow of water going across it. I don't know if they have them in automotive. Most of the ones I've seen are just flat, but so you see how he just lifts up this tab and these two pieces spread open and the spark plug comes right out. Pretty easy. Not all of them are designed this way. There's another one that I actually have another picture of a different one, different way of removing it. Here's a different one. So you pull this out and it actually slides out. I'll show you in the next picture of how this pulls out and it slides out and drops. So you might see a couple different designs on how these are attached out there. Most of you guys might not see them. If you guys go, obviously the airliners, you won't even see any spark plugs. You'll be dealing with turbines. But if you're in general aviation, some people have radials. Stearman's one of them. A Stenson, you might see them on something like that. So he flipped this tab right here. He just pulled this out, and then you can slide it out. You guys take a look at this wire. See how it's not braided at all. So most likely this one's probably going to have a lot of radio interference. It even has a little arrow. So he lifts the clip, and it comes out. There's a couple different designs. It might even be safety wire. You might have to cut the safety wire before you can release the flip. Well, he went all out showing you lots of different ones on how these slide out. Okay. Alright, did you get your pictures? Okay. So, this is actually talking about removing the spark plug. So we want to loosen it with an appropriate size deep socket. Usually this is a 7/8. They actually have sockets that are actually spark plug sockets out there. But a very deep socket will do the same. We don't recommend that you use a regular wrench, box end, or open end to break those spark plugs loose for many reasons. Most likely, when you swing that wrench, you're going to hit something else. Does everybody have that written down? You ready for the next slide? So right here. So you have to get deep down in there to break this spark plug loose. Most likely you're going to crush something, just like happened here. Not to say that you probably can't do it if you're going to try it, that you might not hit something, but the chances of you hitting something are pretty high. Okay. So talking about the socket, you want to make sure that it can fully engage the spark plug hex flats. So there are deep sockets out there, and then there's really deep sockets. You need a really deep socket to get all the way across those flats. Everybody got that written down? Okay. So you see the difference in these deep sockets? Both of them are deep sockets, one of them's just deeper. And believe it or not, the deeper socket happens to be the Craftsman in this point because that's a Snap-on and this is a Craftsman. Snap-on does make a spark plug socket that's specifically designed for spark plugs. When I got mine, it was like 50 or 60 bucks. I don't know how much they are now. But a deep socket does this trick as well. So here's the regular deep socket. It's not fully engaged the flats on the hex. You don't want that because most likely if you're doing that, you're probably going to round it out and it's not going to break it out. So this is just showing you that it is important to have the right tools for the right job. So see how the difference? This one goes all the way over the flats. Okay. So when you guys are taking these out, you want to put them in a tray, mainly because it keeps you from damaging them and also locating where they are on the engine. So if you notice one plug's got oil in it and you put all your spark plugs together, you might not remember which cylinder was having the problem. So when you guys have a tray, you got top, bottom, 1, 2, 3, 4, and so forth, so you can know where that spark plug happens to be in the engine. Also, I don't think you guys want to be holding 10 spark plugs or 8 spark plugs in your hand. Having a tray makes it a little bit easier. Everybody have that written down? Yeah? Okay. So, this is what it might look like. So you got 1 top, 1 bottom, 2 top, 2 bottom, and so forth. So you can see which plugs are having the issues, which ones aren't, and so forth. So you don't have to memorize which cylinder it came out of. You have it already located. And then when you put them back, you know where they came out of. Everybody see that? Okay, also all of these have a copper gasket on them. It is imperative that you make sure you have that copper gasket when you take it off. There are some that have this CHT thermocouple on there, which is basically a gasket attached to a wire. So if you don't have that, you better account for all of your gaskets.
Linda, if you have a CHT thermocouple, will that only be on one of the spark plugs for a cylinder?
The other one will have a gasket on Lecture might run a little bit into lab tonight, so we can get through the demos, just to let you guys know. We still have about an hour in lab, I'm gonna predict, or more. We could finish before then, I don't know. Just to let you guys know. Cause I have a couple groups that are at spark plugs, so we're gonna do the cleaning and the gapping tonight, so you guys can see how that's done. So I'll have a demo in lab or in lecture for that. So does everybody have that down? So some reasons you might scrap a spark plug. So it could be the ceramic could be chipped or cracked. The electrodes could be worn badly. We actually have a go-no gauge here to check those. We'll go over that next week. But for my groups that are already at the spark plug, it's pretty self-explanatory on how you use it. But I'll show you pictures of it next week. Probably won't get to it tonight. But you could have thread damage. If you have thread damage, you're just scrapping it. Everybody has that down? We need some excitement anyway. Okay, I'm gonna give you guys about a 5-minute break. I'm gonna go talk to Mark because we're gonna take that spark plug cleaner out there. I was gonna do it here in the class, but I realized I have 25 people and I don't want them all crowded around that table. So if you guys give me 5 minutes, I'll get Mark to set that up.